Okay, so today we're going to talk about the first chapter of the textbook in biopsychology. And this is the physiology of behavior. This is the material that comes with the introduction of where we get what we know about the brain, how we came about the study of the brain, and sort of the history and evolution behind that. So, the first thing that we're going to talk about is this idea of human consciousness. And so, this is not a new sort of concept, right? So, ever since sort of the beginning of time, we've always tried to figure ourselves out. And philosophers have often tried to understand what consciousness is. And so, one thing that philosophers discussed is this idea between dualism and monism. And so it's really this sort of dichotomy of two different approaches to a problem. So dualism is this belief that the body is physical, but there is a separate component, this mind or soul that interacts with one another. The physical body and the mind interact with one another, but they are separate entities. And so it sort of recognizes this sort of dual nature of reality, while whereas monism is this belief that the world consists of only matter and energy together, and they work as one to produce our sensations and our perceptions. And this all kind of floats around this idea of the mind body question. And that is, what role does the mind play in our experiences? Does it control our nervous system? Is it controlled by our nervous system? Is the mind physical and tangible, like the brain, for example? You can pick the brain up and you can actually hold it in your hands. And the question is what does the mind and the body do with one another? And as we start talking more about more complex systems, for example, emotion, there are several debates about, is it the experience of emotion that comes first that then gives you the sensations of, for example, fear? Do you feel fear? Do you feel fear first as a physical sensation, as the sweating and your heart racing, or is the subjective experience of fear causing that or caused by that? And so all of these kind of what comes first, chicken or the egg, part of this kind of uh, is a question that we really try to answer when it comes to the mind body problem, when it comes to the separation of the mind, the body, and the fact that they work together. Um, and we're going to talk a little bit more about these concepts as we continue on. So, what is consciousness? One thing that you'll find is that consciousness is really, really difficult to define. Um, you might say, oh, well, this definition here is pretty good. So this is just awareness of an ability to communicate about your thoughts, your perceptions, your memories, and your feelings. But let's dive into this a little bit further. So if you have to be present, if you have to be able to communicate that you are aware, okay, what about people who are in experience something called locked in? So there's a scenario. Whoops, hold on one second. Let me zoom out here. Called locked in syndrome, where you're basically in a coma and inputs coming in, and you're consciously aware of all of the things around you, but you're not able to tell anyone what you're experiencing. And it's not until later that maybe if a person comes out of this and recovers, or if we look at brain scans, we find that the person actually is able to figure out what's going on around them, and they are present. But in this case, they actually wouldn't be considered conscious because they're not able to communicate anything about what they're experiencing. They can't blink their eyes, they can't move their fingers, they're locked in. So there are other really interesting phenomena that involve the human brain that can really provide insights into the nature of consciousness. What does it mean? And I often think that it doesn't necessarily help us understand consciousness, but more makes it even more complicated. So one of these particular phenomenon that we're going to talk about two major ones. One is blind sight. Now, I have a video on Moodle that's really interesting. It's a real scenario of a person who has a blind sight. It's usually caused by some kind of damage. It might be like a stroke or physical, like the person got sort of hit in the head, but a lot of times it's sort of internal, like stroke damage, for example. And so when it comes to blind sight, this is when a person can't physically see an object. So if you hold up a pen, for example, they can't see that object. They say, I don't know what you're holding up. Okay. But if you take the object and you sort of put it in their sort of space around them, and you say, hey, take this object, they're actually able to navigate their hands to it. So it's blind sight. It's seeing without being able to see. Now, in the video, what you're going to find is that the person in the video is a real person with blind sight, and what they've done, the scientists actually set up a series of obstacles in the person's way. And so if you're blind and you can't see objects, then you will trip over them if they're in your way. And so a person with blind sight actually can maneuver around objects. And even though you say, well, why did you step aside like that? And they go, well, I don't know. I just did it. They can't explain it. And so what it is it's a particular damage to a particular system. There are two sort of visual systems happening. And when one of those systems are damaged, the perception is lost that in terms of talking about being aware, okay? But the ability of the body to adjust is still present. So we have two major systems when it comes to vision, and these are the ones that we kind of know about and can talk about. So we have the primitive visual system and the mammalian visual system. Now, the primitive visual system, this is one that is what we consider like part of the old brain. Okay. When it's intact, it allows the brain to guide, for example, hand movements toward an object. It is very basic information in. Very simple stuff, just very survival stuff. Now, as we look into the later evolved system, which is the mammalian system, okay, this is what's responsible for our ability to perceive the world around us, okay? It's made up of connections of the visual cortex of the brain and nerve fibers that bring information to the eyes. And so when the primitive system is intact, for example, it still allows for the brain to guide hand movements toward an object, even if the object itself isn't seen or perceived, as in the mammalian system is damaged, but the primitive system is intact. So even though the person doesn't physically see that, they say, I don't see anything in front of me, they're able to dodge something, they're able to, put their hand out and figure out where it's at. And so what does this tell us? What does this mean? And what it is, and this is a really key point here, consciousness is not a general property of all parts of the brain. What it's telling us is that some areas are playing a role in consciousness, but not all of them. So it could be that there are parts that overlap to give us our experience of the world and our perception, but there are things that are going on without our perception that we are actually physically reacting to, okay, but are sort of outside of our awareness. They're outside of our consciousness. Now, another really interesting thing that we can talk about in terms of understanding consciousness, human consciousness, and understanding how the brain reacts and you perceive things, is to study the connections between the two hemispheres of the brain. Now, if you look at a brain, you'll notice that there are two halves of the brain and they're pretty symmetrical. And the cerebral hemispheres, I'm going to show you guys a really nice picture here. And you guys have this anatomy app. This is a really, really cool app where you can explore the brain in ways that you really haven't been able to. And typically, we like to get a human brain and we like to look at it, but even then we can't really dissect it because, we want to use it and continue. We don't have an expendable amount of human brains to examine. But here, what you can do is you can actually take out certain parts of the brain and see what it looks like. So this right here, so this would be the two hemispheres of the brain. So this is, all of this right here. And I'm selecting little pieces of it, but this is all making up sort of one side of the brain, and then this is the other side of the brain. And they're not necessarily identically um, symmetrical, but it really does. There really are. They're really very similar. Okay, and so these two hemispheres here make up the brain, and so this right here would be like, for example, where your eye would be, right? Okay, your ears are over here, and this is the back of the brain. So that's kind of the view that I'm taking here. So I'm going to deselect these areas here so you can see that. Now, when we're looking at the connections between the two halves, these two halves actually communicate with one another, okay, through a series of a band of tissue. And this is a really cool feature. I love this app. So if we're going to go and we're going to zoom in a little bit and real close, you're going to see this sort of, we're going to get rid of this vasculature. I'm going to actually dissect this vasculature out really carefully. And so that way we can get real into there. Okay. Now, if you look here, it looks like two pieces, but it's actually one structure. And if you actually tap on these structures here, they'll give you the description of what they are. Okay. And so here, if you look over here at the side, it'll actually tell you, and this is kind of, okay, so this is the right corpus callosum. They're not split into right or left, as in there's like an actual distinction between the two. They are connected together. So we have the right and then we have the left selected. And what this is you can see here, okay, these two hemispheres are actually connected with this structure. And so this allows the two hemispheres of this band of fibers to communicate to one another, okay? And I'm going to take off this hemisphere. It's going to take off part of it's going to take off part of the corpus callosum, but you're going to see, okay, what that looks like right there. So that's a really nice picture of the corpus callosum right here. I'm actually going to dissect off right here just so you can see it. Okay, and so this right here is the corpus callosum, which allows for the two hemispheres to communicate. So let's go back to these slides here. Now, there are cases where we have to, and I say we, I'm not a neurosurgeon, but neurosurgeons have to actually remove out, cut the corpus callosum. So this in corpus callosum is actually stands for tough body. It's translated to tough body. And this is the largest commissure in the brain and connects those areas of neocortex on either side of the brain of the hemispheres. And so in very drastic situations, we have what we call split brain procedures. Now, a split brain procedure is not something that is done sort of like, as a first line of defense. Okay. This is a person who has to have the split brain procedure. It has to undergo brain surgery. Usually they have severe epilepsy that cannot be controlled by medications or very, very hard to control. And so when you look at the electrical activity of the brain, and in really severe cases of epilepsy, you might have a seizure start in one side of the hemisphere and it crosses the corpus callosum and then causes the other side to experience basically overfiring of neurons, too much electrical activity. And so if we get, for example, a focal point or even not a focal point, just, areas where they keep crossing over this band of fibers, what surgeons will do will actually cut the connection, sever that connection to reduce the severity of the seizure. So they no longer can move, that electrical activity no longer moves to the other side. And so that's great because it reduces the severity of the seizures. And now you have only maybe reduced seizures. Maybe one side is seizing, but the other side is staying seizure free. Or, you can actually, in some cases, really, really severely cause the seizures to become completely infrequent. So it's a very, very successful treatment many of the times. But the problem is now the hemispheres can no longer exchange information. And so one really interesting thing when it comes to the brain is that the two hemispheres, we're gonna undo that and bring this back. The two hemispheres are responsible for different things. Now, there are some what we call sort of this where we have like the structures responsible for one lateralization is what we call it when we have, oh, the right hemisphere is in charge of this and left hemisphere is in charge of that. We have a little bit of that that's pretty that's like guaranteed. So for example, the left hemisphere is really important for speech. To say that the left hemisphere is solely responsible for speech is not necessarily true, but we do know that there are areas, specific areas in the brain in the left hemisphere specifically that are really important for speech. Okay. So, for example, if you have a stroke in a particular area of the left hemisphere, it may lead you to either have issues with, being able to produce speech or be able to read properly. Now, we know that the right hemisphere, for example, is really important for things like instructions, but not necessarily as important for things like reading in speech. Now, the interesting thing is that when you a lot of the 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 functions that we have are what we call contralateral. So information coming into this hemisphere, the right hemisphere, controls this side of your body, controls your left side. Things that are coming in from your left side control the right side of your body. A lot of things are what we refer to as contralateral. One thing that isn't contralateral is olfactory or detection of scents and odors. So there's a really good video that I have on Moodle that gives you a scenario of a person who actually has had the split brain procedure done, and you can see some of the really interesting side effects of that. Um, one interesting thing is some people report, for example, that their brains, it's like having two separate brains. They're not communicating with one another. Okay, they're almost independent brains. So, for example, the right hemisphere doesn't really know how to read. The left hemisphere is more responsible for that. So, if you're holding a book with your left hand, remember your right side of your brain's controlling that. Your right hand, your if the right side is controlling your left hand, people have reported that they'll actually put the book down, even though they really want to read it, because the left hand grows bored because the right side of the brain doesn't know how to read. We also see cases where people, there's one case where a man went actually to hit his wife with one hand and then stopped himself with the other hand. So again, almost having sort of two independent brains here. We also find, like I said, with olfaction and being able to smell. So this is not contralateral. This is where we see, for example, if you smell through your left nostril, because the left hemisphere is very important for speech, you can tell somebody what you smell. Versus if you smell through your right nostril, because this doesn't really involve as much with speech, you might actually not even, you might deny that you even smell anything. But your left hand could point to what this scent actually represents. For example, if you're smelling a rose, you might say, I don't smell anything. But if I say, well, just select something from the picture where you think the smell might be, the person would, with their left hand, select the rose. And that's because that is, that's a really interesting sort of combination of parts of the brain that aren't really communicating with each other. There's a part of awareness there, but then there's not the consciousness to be able to talk about it. So these are some really interesting sort of ways for us to think about consciousness and study consciousness. Now let's move on to the next slide, which talks about behavioral neuroscience in general and how we study this. So these phenomena are really interesting, and they really get to formulate even more questions about what's going on in the brain. So let's talk a little bit about what our goals are of research. So of course, we want to be able to observe behavior. We want to explain behavior. We want to understand why people do the things that they do and understand their physiological underpinnings. So when we look at this, it's important to look at generalization versus reduction or deduction. So these are kind of two separate philosophies, and we want to be able to combine them to be a really good scientist. So when we look at generalization versus reduction, for example. So generalization is painting these really broad strokes, general laws, okay? So if you guys remember back, even in Introduction to Psychology, we learned about classical conditioning and pairing a response with an action. For example, you pair a fearful response with getting stung by a bee, and now you're scared of bees. This is a really broad generalization, right? So it's a very big sort of concept, and it's just a very, very general thing. Now, when we talk about reduction, we're talking about breaking things down into really digestible small structures, reducing it down. And for example, physicists use atoms to describe energy and matter and really break down in these tiny little pieces and reducing and deducing all of these phenomena down to really basic elements. So the idea is to generalize, right? That has its place in this, okay? And also the ability to be able to break things down into smaller parts. And if you use these things together, then we're going to understand phenomena much more clearly. Now, another thing is understanding that behavior, the same behavior, okay, can happen for different reasons. So, for example, mice build nests under two main conditions. When the temperature is low, so when the air temperature is low, when it's cool outside, um, or when they're pregnant. And so, it doesn't matter what the temperature is outside. If a mouse is pregnant, then that mechanism of building a nest is going to be activated. So these scenarios actually activate different parts of the brain. So, for example, if the air temperature is very cool, pregnant or not, the temperature sensors in the mouse's brain is going to trigger this cascade of actions to build a nest. When a mouse is pregnant, the hormones are going to trigger this behavior, same behavior, but for different reasons. We also see this happening in things like depression, for example, right? So we see depression has similar symptoms, but could have different reasons for activation. So seasonal affective disorder, the seasons and the temperature and the light is what is going to sort of trigger that particular episode versus we can look at medication and we can look at changes in hormones and we can look at, for example, after a woman has a baby, then we can see that that person becomes more susceptible to depression differently because they're experiencing a different cascade of hormones than when that person's on a menstrual cycle. So, I mean, we see these sort of overlapping mechanisms in the brain and similar symptoms, but different causes. And going back to this idea of blind sight, for example, tells us that there are different mechanisms that are responsible for different phenomenon, for example, consciousness, and that some of those likely overlap. So understanding the underlying physiology can help get us to what is behavior and what does that mean. So I'm going to end the session now, and I'm going to pick back up on the biological roots of physiological psychology. I'm trying to make these videos a little bit more digestible in smaller chunks so that you guys can kind of watch them as you go. So we'll pick back up on the biological roots of physiological psychology.